See, work here is discussed because work is a kind of a medium, is a source, or is basically is a process through which the transformation of energy takes place. And through this, we can find out that how much of the energy has changed, and so that we can find out the internal energy change. That is why the work has been discussed here. We can also find out heat exchange. How the heat is being given or how the heat is being taken out, how much of heat has been given, how much of heat has been taken out. From that also we can find out what the internal energy change. What we need to know is that usually this delta U is calculated by using the first law of thermodynamics. Everybody knows that we have basically 4 laws of thermodynamics. It starts from 0th, 1st, 2nd, and 3rd. The first, we normally start with the first at the usual level. So the first law of thermodynamics says that the total energy of the universe is always constant. And this definition of the first law of thermodynamics gives us the formula that this internal energy change is always is equal to heat given and the work done, amount of the work done. So this is the formula which will give us an idea about the energy change or heat change. I can describe it to you like this. Like if suppose we're having a cylinder which is having a frictionless piston fitted on it, is having a gas whose internal energy was U1, and what we have done is we have given Q amount of energy to this gas at constant pressure. What will happen is, we know that definitely what will happen is the gas will expand, it will move to this side. This much amount of work has been done. The work has been done by the gas, W amount, and then it's what we find is that because of this change, it's in this internal energy comes down to U2. So U2 is the final internal energy. So what we can write is that the final internal energy will be equal to whatever the energy it was having initially, whatever the amount of energy has been given to this, and whatever the amount of the work has been done by the gas. So what we find is that we can bring U2 here. So it's U2 minus U1 is equal to QP plus W, and this gives us the change in the internal energy QP plus W. So from here, so with the help of the first law of thermodynamics, yes, we can find out the change in the internal energy, and that is what is being required in order to go into the quantitative aspect of how the transformation of energy takes place from one form to the other.